Hey there, this is Rantaj Singh,
And this is Erico.
and today we'll be presenting segment number 1 of the emission spectroscopy lab. So to begin with, the lambda max in emission spectroscopy is a wavelength that describes the highest emission intensity of a photon in specific peaks of an emission spectrum. And it also is the wavelength which the greatest number of photons are emitted at. Lambda max is proportional to the energy of the photon which is being emitted. So, what determines the emission spectra in lambda max? First of all, it's not the observable color. It is instead the molecular structure, and this is because the molecules of the dye will emit certain colors at specific wavelengths. Each molecule of different dye will interact with light differently. The observable color from the dye is dictated by how the electrons of the atoms that make up the molecule absorb and emit light. When an electron absorbs a photon with enough energy to excite to another energy level, they will emit a photon of a quantized wavelength and return to their ground state. So as we can see here, with an electron being in the fourth energy level, it will relax down to the ground state. And because this is the shortest wavelength, as we can see, it will also have the highest energy. And once the electron is in the ground state, it will be the most stable and the most energetically favorable, because in the ground state, this electron has the lowest potential energy. Therefore, the quantized wavelength of the photon most emitted determines the lambda max of each peak.
Looking at our emission spectrum, we can see that the green line, which has a peak at around 508 nanometers, corresponds to the green dye. The purple line, which has a peak at around 616 nanometers, corresponds to the red dye. Interestingly, the red line, which is the line of the mixed dye, has two peaks at 508 nanometers and 616 nanometers. It would make sense for the mixed dye, which was a one-to-one mix of red and green dye, to have corresponding peaks with the two. An analogy for this scenario, would be the skin color of biracial children. Even though we see one skin color, they are still made up of multiple races, which are like the two peaks in the spectrum of the mixed dye. In the same way, that is why we can only observe one color in the one-to-one mix. Moving on, how does molecular structure determine lambda max? Because different dyes have different molecular structures, this allows for different bonds, types of bonds, and ways of bonding. One main difference that directly impacts molecules and their structure is resonance. Resonance is when a molecule has multiple bond structures, and in reality, that molecule takes on the hybrid molecule, which is the molecule that displays average bond lengths. As you can see, the orange molecule displays resonance because we can always move this carbon ring to the other side of the molecule, while compared to the green molecule, where even when we move any of the carbon rings, the molecule would still be the same, meaning that this is the molecule of the green molecule, which doesn't show resonance, and so resonance lowers the total energy of the system.
And so since resonance decreases the total energy in a molecule, electrons will therefore have stronger attractive forces to the nuclei because potential energy is decreased. And because of this decrease, they will have decreased quantized energy levels as well. So based on this, if an electron is excited in a resonance molecule, when it relaxes to the ground state, it will emit a photon of less energy and have a higher wavelength, which directly dictates lambda max, as we can observe in an orange and green emission spectra. So just recapping, molecular structure can display resonance. Resonance lowers the total energy of a molecule, and the lower total energy means there are stronger attractive forces between electrons and nuclei, and therefore electrons will have a decreased quantized energy level, and the photons they will emit will have less energy and higher wavelengths, dictating lambda max. Thank you.